Hey guys, this is Coach Lowe, and this is Contextual Geometry. This is Chapter 3, and we are in Section 7, Perpendicular Lines. So let's get started. All right, we're talking about lines that intersect, and they form right angles, 4 right angles. So special type of intersecting line, perpendicular lines. And they'll form 4 right angles. A lot of times you'll see that little box drawn in the corner showing that it is 90 degrees. These lines M and L, are perpendicular to each other. That little upside down capital T is the symbol for perpendicular lines. So you don't have to write perpendicular out every time. You can just write an upside down T, and we know that you mean lines that are perpendicular to each other. All right, so if 2 lines are perpendicular, then they form 4 right angles. That's Theorem 3.8. Definition of perpendicular line says perpendicular lines that intersect or lines that intersect to form 4 right angles are called perpendicular lines. So kind of saying the same thing there on those. So let's look at some problems dealing with these perpendicular lines. Also, by the way, if I just draw a random line like this, and then we put a point on the line, you can actually draw one line that's perpendicular to that point. One line can be drawn. So if you think about it, if I set my protractor on here and I marked 90 degrees, there would be only one spot that I would be able to mark that would make this a right angle, a 90-degree angle. So it doesn't matter what point you pick on the line, there's exactly one line that you can draw through it to be perpendicular to the given line. All right, so let's check some problems out here. I'll draw this picture, and you can pause the video and draw it as well if you would like to. All right, so here are some things on this line. If you want to pause the video and write these down, that's totally fine. But here are some things that we know about these lines and their intersections. Line AG, so here's line AG, is perpendicular to CE. All right, so we already know some things about that. Where they meet, we can mark right angles. So we know these 2 angles are complementary. They have to add to be 90, and these 2 are also complementary. And then this one is 90 and that one's 90. All right, AC and BF are perpendicular. So even though not drawn to scale, where those 2 intersect, 90 degrees. All right, 4 90-degree angles. B is the midpoint. B is the midpoint of AC. So segment AC is here, and B is right smack in the middle. All right, so the first question that I have for you is this true or false is the question. Here's the statement. Angle 1 is congruent to angle CBD. Angle 1 is congruent to angle CBD. All right, so let's locate angle 1. I kind of drew over right here. Here's angle 1, and here is CBD. So this angle right here, CBD. Let's not forget how to name angles here with 3 letters. So are those angles congruent? Yes, they are. First of all, we know that they're 90 degrees because those lines were perpendicular. But they are also vertical angles. So this is true. They are vertical angles. If I trace those 2 angles, they only touch at the vertex, 2 intersecting lines, bam. Vertical angles are congruent and they're equal in measure, so we're good. Angles 2 and 3 are complementary. Angles 2 and 3 are complementary. All right, so complementary means they add to 90 degrees. So let's see if we can locate angles 2 and 3. Here's angle 2 and here's angle 3. What do you guys think on that one? Good, that is false. Why is it false? Angles 2 and 3 are not complementary. They are what? Exactly, supplementary. They add to be 180. In fact, they are a linear pair. So they're a special type of supplementary angles. Those two angles add to be 180. All right, let's try another one. So number 3 is the measure, remember the little m, the measure of angle GDF and plus the measure of angle FDE equals 90, which also means these are complementary. That's what they're saying, right? So GDF is this angle right here. FDE is this angle right here. And yeah, they're going to add to be 90 degrees. We already looked at that. These lines are perpendicular. We already marked it. So that is true. All right, number 5. Angle 1 and angle 5 are congruent. Oh, sorry, number 4. Angle 1 is congruent to angle 5. Angle 1 is congruent to angle 5. So remember, angle 1 is here. Angle 5 is here. Angle 1 is congruent to angle 5. So we know that angle 1 is 90 degrees because these lines are perpendicular to each other. And it also told us that these guys were perpendicular, which makes angle 5 90 degrees. So are they equal in measure? Yes, which means they are also congruent. So this one is true as well. All right, let's see one more. Angle 3 is an acute angle. Angle 3 is an acute angle. So looking up here at angle 3, here's angle 3. Is it acute or obtuse? This is false. It's obtuse, isn't it? Remember, acute angles are less than 90 degrees. Obtuse angles more than 90 degrees. All right, so some other things that you should be able to do for me. You should be able to name 4 right angles. You should be able to pick out supplementary angles and linear pairs. You should be able to find complementary angles. I actually have one more question for you before we go. Of course I do. If the measure of angle 3 is 120, could you find the measure of angle 2 for me? If the measure of angle 3, which is here, is 120 degrees, could you find the measure of angle 2? The answer is absolutely we can. Angles 2 and 3 are a linear pair. They form a linear pair. They're supplementary to each other, so that means they add to be 180, so we'll subtract. The measure of angle 2 is 60 degrees. Do you know the measure of this angle? Absolutely. 120 degrees. What are these two called? How are they related? They are vertical angles. Angles 6 and 2, what are they? Vertical angles. Very good. All right, guys, this is Coach Lowe, and I'm out.